Okay, so now our box reaches the top of the plane. So the box is here and it's travelling at 2 meters per second up the plane. And it leaves the surface. The rope breaks and leaves the top of the plane. Assume air resistance is negligible, so therefore there is no friction. So now we become a projectile. So the only force we have is gravity. Okay, find the time it takes to hit the ground. So this is the distance that it's going to fall, and I've been told that it's 25 meters, that's 20, so that's going to be 25 sine of 20 degrees. That's the distance that it needs to fall. Okay, so we're now a projectile. So I need to be careful because I've got sideways and up and down. My initial velocity is going to be 2 cos of 20 degrees in the I plus 2 sine of 20 degrees in the J, because this 2 is going in that direction where that's 20 degrees. So I can break that into a 2 times the sine of 20 and 2 times the cos of 20, and sideways is going to be the I component, and that's going to be the J component. Okay, and my acceleration is going to be negative 9.8 in the J. So find the time taken to hit the ground. Okay, so I can do that. We'll hit the ground. So S equals UT plus a half AT squared. The S component is going to be, okay, so I've got some ups and downs. Up is going to be positive and down is going to be negative. So negative 25 sine of 20 degrees equals 2 sine of 20 t plus a half minus 9.8 t squared. On a calculator, solve for t. So I'm considering the J component where that is positive. Therefore, it's initially, when it leaves, it has some initial positive J velocity. A component of the 2 will be up, and the acceleration is only in the J because it's to do with gravity. So on a calculator, so I've got minus 25 sine of 20, that's the distance, equals 2 sine of 20 times x, and that gives me a time of negative time, or 1.3926. And I've got to do that to 2 decimal places, so t equals 1.39 seconds. Okay, so how far does the box travel in the horizontal direction? Okay, so what's happening is this box travels like this and lands here. I know it takes time of 1.39 to land here, and it's travelled that far velocity-wise. There is an I component of the velocity, so that's the position. If I was to consider, if the position vector is 2 cos of 20 in the I plus 2 sine of 20 in the J, that's the velocity, then this will be 2 cos of 20 t in the I plus 2 sine of 20 t in the J. And I'm going to call this position here 0, 0, therefore plus c, and c is 0. So this is how fast it's travelling horizontally. So therefore it will land 2 cos of 20 times 1.39, how long it's travelling, which will be, on a calculator, get into the habit that when you have more decimal places and you're on a calculator, choose all of the decimal places, not just the previous rounding, and that gives me 2.61728. And to 2 decimal places, 2.62 meters is how far horizontally it will travel.